Okay, Algebra 2, we are getting ready for our unit test on Unit 4, piecewise function. So please, I don't know if you're using these reviews, but these checklists, if you can read this and understand what's going on, then you're pretty good shape, and then there are problems that deal with that. So things that we did, interval notation, knowing interval notation, going from an inequality to interval notation to a number line. So if you had something like x is greater than 5, you know that looks like 5 to infinity, and on a number line it would look like this. All those representations that we did early on. If you're given a relation, tell me whether that is a function or not. When you're given a relation, finding the domain and the range. Finding the domain and range if you have a graph. And other things with the relation and function. Remember, we had like a set notation, we had graphically, and we had like mapping diagrams to do that. So all of those things that we did for is it a function or not. Given a piecewise function, evaluate it at given points. You have to pay really close attention to the restricted domain here. Graphing a line on a restricted domain. So graphing a line from, -2 to 4. What would that look like if you graphed it, if I gave you the equation of a line? Graphing piecewise functions. And then skills you need when you're trying to decipher a graph. You need to be able to look at the equation of a line. If you have 2 points, give me the equation. If I give you the slope and a point, what's the equation? If you're given the slope and the y-intercept, all of those. So writing equations from graphs, equation of a piecewise function from a graph, and then make sure you pay special close attention to when you write a piecewise function, how the domain is split up into different pieces. Okay, so let's take a review. Graph each inequality and convert to interval notation. X is greater than or equal to 5. Somewhere on this number line is a 5. It is a closed circle I shade to the right. In interval notation, this is the interval from 5 to infinity. X is less than 2. Somewhere on this number line is a 2. Closed circle, shade to the left. This is the interval from negative infinity up to 2, including 2. Okay. And then the next one. X is less than or equal to 6, greater than or equal to -4. You might be better if you put this in the order from the smallest number to the left and the largest number to the right. So these are all the numbers between -4 and 6, including, it is including, I messed that up. Sorry, it's including 6, but it is not including the -4. So that's it. So it is strictly greater than -4. So there would be an open circle here. There would be a closed circle here, and everything shaded in between. That is the interval from -4 to 6, including 6, but not including the -4. X is less than or equal to -1, or X is greater than 9. So the first one, less than or equal to -1, that's this situation. Greater than 9 is this situation. That represents 2 intervals. That is the interval from negative infinity to -1. Union, join it with the interval from 9 to infinity. Evaluate a function for a given value. Okay, f of 2. So you have to figure out which of these intervals includes 2. 2 is in the interval, that first interval. Well, we can write this in interval notation. -4 to 4. The second interval is 4 to 10. So 2 is in that first interval. So f of 2 is going to be, plug 2 into that first equation. So -2 times 2 plus 3, that's -4 plus 3, which is -1. F of 4. 4 is in the first interval. Okay, so that is -2 times 4 plus 3, so that's -8 plus 3, which is -5. F of 10. The domain of this function and all the numbers between 4 and 10, not including 10. There is no definition. So f of 10 is undefined. So graph this equation for the stated interval. Graph f of x is negative 3x plus 2. This line has a y-intercept at 2. I could do it that way, or why don't I just back up and why don't we just do it this way? I've got those two endpoints, so why don't I look and just substitute those in, because I'm going to need those values. So negative 3x plus 2. Let's see what happens at 2 and 3. When I plug a negative 2 into that equation, I get 6 plus 2, which is 8. When I plug a 3 in that equation, negative 9 plus 2 is negative 7. So because these are brackets, these are going to be closed in. So at negative 2, 8 is right here. And 3, negative 7 is right here. And so if I join these together, something like that, that is the line. So that is the line graphed from negative 2 to 3, closed dots on either end of this because of those brackets. Okay, so it's closed on either end of that. Graph 5x minus 4 on the interval from negative 1 to infinity. So 5x minus 4 from the interval of negative 1 to infinity. So if I've got x and 5x minus 4, what happens at negative 1? When I put a negative 1 in that equation, I get negative 9. And so negative 1, negative 9 is right here. And then I just need to pick some other point on this line. So let's just pick, if I pick something like, we'll pick 2. That gives me what, 10 minus 4, which is 6. So 2, 6 is right here. And so this line I am graphing, I'm starting from here. I'm going through the point you see right there. And there we go. And that's it. So I've graphed the line from negative 1 to infinity, and there is a closed circle at negative 1 because of that bracket. Graph this piecewise function with the information, and then give the information that is asked below. So graph negative 2x plus 5 on the interval from negative infinity to 2. Okay, so from negative infinity to 2, it's going to cross the y-axis, I know, at the point 5. So I know that it crosses the axis here. It has a slope of negative 2. So that means if I were to go down 2 and over 1, I get this. And down 2 and over 1 here, that's 2. So what happens when you plug in a 2? If I plug in a 2, I get 5 minus 4, which is 1, and that is correct. Okay, so I'm graphing this one from negative infinity up to 2. So it's going to look like this. And there is a big closed dot right there at that point. And then from 2 to infinity, I'm graphing x plus 2. So what I can do there, I've got to graph x plus 2. What happens at the number 2? When you plug a 2 in, you get a 4. That's going to be an open circle. So you get an open circle right here. Let's just pick another value. When you plug in a 5 here, you get 7. So that's right here. So we've got this line right here. So there is our piecewise function. What is the domain? The domain, you look at your x-axis. I'm going to get domain values because that left line goes all the way from negative infinity and all the way over here. So these lines are going to keep on going forever. The domain is going to be from negative infinity to infinity. How do you find the range? You go to the y-axis. There are no y values on this graph until I get to 1, okay, and 1 is included. So the range is from 1, and then it looks like I'm going to get y values continuously all the way to positive infinity. So from 1 to infinity is the range of this function. Same thing, graph another piecewise function and give the domain in range, okay? So let's graph negative x plus 2 from negative infinity to negative 4. So a couple of things. You could just pick -4 and then pick another point. We can certainly do that, and you could do all of these that way. Let's do it this way for consistency. So I've got a graph -x plus 2. That's my first graph. I'm going to just choose different colors. And then I've got a graph, the other one is f of x equal -2. That's a horizontal line. And the last one, I've got a graph x plus 3. Okay, so that first one is from -infinity to -4. Let's put a -4 in there, and I get 6. Okay, and let's just pick another number. Let's pick, say, if I put a -6 in there, I would get, what, 6 plus 2, which is 8. So that gives me 2 points. So -4, 6 is right here. This is going to be an open circle. And -6, 8 is right here. So this is the first line. The next line, f of x equal -2, that is a horizontal line. So between -4 and 1, I'm graphing the horizontal line. So I have a closed circle here, and it is that horizontal line. That is f of x equal -2, graph from -4 to 1. And then what happens at 1, and let me just back up. I wanted to do different colors there so you could see for consistency. So that was, what is that, -2 from here to here. And then let's go to the green one. I need to graph x plus 3 from 1 to 5. So let's pick those 2 points. Substitute a 1, you get a 4. Substitute a 5, you get an 8. So the point 1, 4 is going to be an open circle. And the point 5, 8 is going to be a closed circle. And that is it. Okay, so now what is the domain of this function? So to find the domain, start traveling on the x-axis. So it's -infinity. I'm getting numbers continuously until I get to 5. So -infinity to 5 is the domain of this function. It includes 5. The range of this function. So to find the range of this function, start at the y-axis. There are no y values until I get to -2. So my first y value is -2. Okay, then I keep traveling. I don't get any more y values until I get to 4. Okay, so I get a y value at 4, but it's an open circle. And then if you look, keep traveling on the axis, I'm going to go to infinity because of that. This one right here keeps on going. So it's going to be from 4 to infinity. So the range is -2 and then 4 to infinity on this graph. Now, going backwards, I'm giving you the graph, and I want you to give me back the function, the equation of this piecewise function. So what I will look at this is I look at this graph and I see 3 things. There are 2 lines and there's a dot. So I've got to have 3 things in this notation with the right intervals. Now what you can do, you can just look at this straight up and say this line right here, that is the interval from -infinity to -2. So I'm not going to miss that. I'm going to get that part right. So from -infinity to -2, and there's an open circle on that -2, so this is the first domain. Okay. Then if I look at this second line, I can look at it and see that line is being graphed from -2 all the way over to 4. Okay. So from -2 to 4. So from -2 to 4, and that line is going to have a closed circle at the -2, and it has an open circle at 4. Now, there's a problem. I said that line was graphed all the way to there. That's not the case. Okay, when I look at it, there's an open dot right in the middle of that line. So it's not graphed all the way from -2 to 4. It looks like it's graphed from -2 to 2, and then from 2 to 4 with a bracket. So 2 is excluded from that line. And then what happens at x equal 2? There's something special happening at x equal 2. So it looks like f of 2 is going to be 0. So that dot, so I know that f of x is 0 at x equal 2. Now I just need to figure out these other 2 lines. So how do we do that? So if I look at it, if I can figure out the slope and the intercept, that's pretty good. So what I can do, if I look at this line right here, it looks like I can go up 2 and 1, 2, 3, 4. So I'm back to the line, same thing, or up 1 and over 2, up 1 over 2, up 1 over 2. So it looks like this slope is negative 1/2. Okay, so on this line, slope is negative 1/2. So what would the y-intercept be? So the y-intercept would be, so if I go down 1 and over 2, that's where it would hit the axis. So that would be at the point 1. So b is equal to 1. So that first line is going to be y equals negative 1/2 x plus 1. Okay. Now that's one way of figuring out the equation of that line. The other thing you could just figure out, what are the 2 points? Negative 2, 2 is on that line, and it looks like what? Negative 4, 3 is on that line. And so this tells me that the slope of this line is going to be 3 minus 2 over negative 4 minus negative 2, which is negative 1/2. Okay, so that is the slope. And then I could use point slope. So either way I could do that. I could say then the equation of this line is y minus 3 equal negative 1/2 x plus 4. And then when I simplify that, I get y is equal to negative 1/2 x plus 4 plus 3. Okay, you could leave it like that. That would be fine. If I went a little bit further, this is what? Negative 1/2 x, and then negative 1/2 of 4, that's going to be minus 2 plus 3. That gives me negative 1/2 x plus 1. Okay, so that is the same equation that I got right here, negative 1/2 x plus 1, from negative infinity to negative 2. Now this next line, if I look at this one, so if I look and figure out the slope of this line, it looks like the slope is going to be by going what? Up 2 over 1, up 2 over 1. It looks like that's what, so the slope of this line is going to be 2. It crosses at negative 2. So in this line, m equal 2, b equal negative 2. So the equation of this line is 2x minus 2. And that should be it. Okay, so I've got 2 lines, and then the point here, f of 2 is 0. What is the domain of this function? So domain, go to the x-axis. I have domain values starting at negative infinity. So from negative infinity, and let's see, it looks like the domain, I'm getting values all the way here to negative 2, but there's a value down here, so I'm continuously getting values. And then it looks like, okay, well, what's happening here? I do have a value at 2, and it looks like I can keep getting x values until I get to 4. So the domain of this thing is negative infinity to 4 with a bracket. Okay. What is the range of this function? The range of this function, go to your y-axis. Okay. There are no y values until I get to negative 6. So the range starts at negative 6. Okay. And then it looks like I continue to get y values all the way up to 0, and then something happens here. There is no y value on this graph at 2. So this domain goes from negative 6 to 2, so it does not include 2. But then it looks like the values will start again, and because of this graph on the left going to infinity, I'm going to get from 2 to infinity being the range. So negative 6 to 2, and 2 to infinity. Look at this relation and answer some questions. What is the domain of this relation? Set of all input, 0, 1, 2, 3, negative 1. Okay, you could write 2 down twice, or you didn't have to write down 2 twice. What is the range? 1, 0, negative 1. Okay, so 1, 0, you could write down the repeated values, doesn't matter. Is this a function? No. It's not a function because we have repeated domain values. Okay, So you notice that we have the point 2, 0, and 2, negative 1, okay? So this is not a function because of that. Look at the graph below and let's come up with some information. So this is not a piecewise linear, but it is a piecewise function, so no worries about some of the squiggles that are going on. We can still read it. What is the domain of this function, okay? I don't see any domain values start until I get to negative 2, okay? So negative 2, and then as I travel left to right, it looks like I'm getting values continuously all the way until I get to 3. And then there's one other domain value at 4. Okay. What is the range? So if you go to the bottom of the y-axis and start traveling, you don't see range values until you get to negative 5. And then if you travel, what are you getting? You're getting values continuously all the way up until you get to 3. So the range is negative 5 to 3. Is this a function? Okay. It would not be a function if I had a place where I could draw a vertical line and get 2 values. So if you look at all the points of discontinuity, so that's okay. I'm only getting 1 value there, and I'm only getting 1 value there, 1 value there. So yes, this represents a function. So it passes the vertical line test. And let's see what else. That is it. Okay. So that's it for our review of piecewise functions for Unit 4.